This is part 2 of chapter 1 of the Systems Analysis and Design course. Calculations that you need to know would be the title of this video presentation. This is a companion to Systems Analysis and Design 7th edition by Dennis Wixom-Roth for BUIS 3200. I'm Dr. Renaud from Shawnee, and I'll be taking you through this presentation. The first calculation that you really need to know is something called the weighted average. The weighted average basically is the sum of the values times the weights divided by the sum of the weights. So you take each of the values and each of the weights, multiply them together, add all of those up, then add up all the weights and divide the two. Now, often the weights are expressed as a percentage. And when you add the decimal percent, like 30%, 40%, and another 30%, you would get 0.3, 0.4, 0.3, which would be 1.0. So if you use decimal percentages with the total being 1, dividing by 1 is easy. But it's not always that way, and we'll do two weighted average examples. In the first weighted example, I'm using percents. So I'm taking 100 and multiplying it by 0.3 to come up with 30. 200 times 0.4 would be 80. 300 times 0.2 or 20% would be 60. 400 times 0.1 would be 40. I then add all those up and I come up with 210. So that would be 210 divided by 1.0 or 210. So the weighted average is 210, where if we took the mean of those values, 100, 200, 300, 400, the average would be 250. If we took the mode, that would be 200. If we took the median, 6 and 4 is 100, 8 and 3 is 110, so the answer would be the median value would be 200. So you can see how the weighted average gives us a different number that's again based upon the weights of things, and it's often used when there's a percentage chance of something happening. 10% chance of it costing this much and 40% chance of it costing this much, then you could weight the average and come up with a weighted average. Here's another weighted average example, but instead of this time using decimal percent weights, I'm just using numeric weights. So the first column is the value, the second column is the weight. So 10 times 7 would be 70. 12, the value times a weight of 8 would be 96. 14 times the weight of 3 would be 42, and 19 times the weight of 1 would be 19. Total of 19, so that would be 227 divided by 19, or 11.95 would be the weighted average, because there are so many more 10s and 12s than there are 14s and 19s. This would be kind of looking at a population of people. Maybe you had 7 people that scored a 10, 8 people that scored a 12, 3 persons scored a 14, and you've got 1 person that scored a 19. Well, then the weighted average kind of shows what the population would be, because the mean would give us a number significantly higher than that. And the mode would give us, or the mode and the median would give us 12. So the weighted average kind of gives us a good average for especially financial calculations when there are lots of percentages and things and chances of something happening. The next calculation that you need to know is the present value expression, which is over here. It's based upon the future value formula here, and it's just a little bit of algebra to convert between the two formulas. We've probably seen this in our business and other math classes repeatedly. Let's just go over the future value. If we take a present sum of money and invest it at an interest rate I for n periods, it's worth more, right? So if we were to take a dollar, invested it 10% for 1 year, we would have $1.10. If we invested it for 2 years, we'd have $1.21. or something close to that, by using the 1 plus I to the nth of the present value to come up with the future value. But if we know a future value and when we need it, we can plug it in and solve for present value, which is what the current first function there called present value does. Let's look at that function and just say it in words what it means. The present value is sum of the money in the future. The FV, future value, is discounted by what you can gain or what you can earn on your money that you have today. For instance, if we needed $1 million in 10 years, I could invest a sum significantly less than that today at a reasonable interest rate, and have $1 million using like the rule of 72s, which is a kind of a shortcut hand rule, that if I needed $1 million in 10 years, if I had a $500,000 today, I could invest it at 7.2% interest, and I'd double it in 10 years. So you can stop and think about that. This present value function is used throughout analyzing business situations, and the analysts use this a lot, because what if we have two choices? I can buy a system today for this much, or I can put it off and spend this much in 2 years. Which is a better deal? Well, what you do is you return everything back to money today. So the system in 2 years might be X dollars. It's going to be less than that today because of the discounting of the future value. So you can compare the discounted value of the future amount today to the amount today. Now, there are a lot of these situations where you've got to do multiple calculations. If you spend 100,000 today and 200,000 next year and a $500,000 next year, how's that compared to spending $700,000 today? So sometimes they get complex, but you solve each bucket, you solve each one of the years, and then add them all together because they're all present value once you discount them. Let's look at a couple of simple examples. And there is a YouTube video specifically on present values that's also in the content area of this class. So here's the question. I need $72,000 in 4 years. I just need 72K in 4 years. How much do I need to invest at 8% today to have $72,000 in 4 years? Well, let's look at the numbers. We take 72,000 divided by 1 plus 0.08 to the fourth power, which would then be 72,000 divided by 1.360, which would give me approximately $53,000. So if I put $53,000 into an investment today and let it ride for an investment at 8%, which is a pretty good interest rate, but if I can invest it at 8% today and leave it there for 4 full years, then I'll have $72,000 in 4 years. Now, imagine you can buy a system today for 60K, but you can limp along and get a much better system in 4 years for $72,000. Assume you can make that same 8%. Well, that $72,000 system in 4 years at 8% discount really is only a $52,000, $53,000 purchase today versus the $60,000 system purchased today. So by converting them both to present values, then I can say, well, it looks like it's actually cheaper for me to hang on for 4 years. It's actually a better deal. Let's look at another example. Here's another example. I can buy a car today for $28,000. There's a car I really, really want for $28,000, but there's a car that I have dreamed of my whole life, and it costs $33,000. What if I took my $28,000 I have in my hand today to buy a new car and invested it for 2 years? Um, let's do that. So I take the present value, and that'd be PV2 here, the $33,000 that I need in 2 years, 1.1 to the second power is 33 divided by 1.21, or 27.3. Let's look at that at $27,300. So if I took my $28,000 today, invested it for 2 years at 10%, I'll have $33,000. Actually, I'll have more than $33,000 because if I invest 27.3, so I can spend $700 today and invest the rest, and I can still buy the $33,000 car in 2 years. Spend $700 today. I can, so it's a lot cheaper to wait. It's cheaper to wait, at least in this situation. Now, if the interest rate was lower, then we wouldn't get as large a discount, and it might not be cheaper to wait. It might just be better to go ahead and buy the car today. So these present value problems, you've got to calculate everything out to its present value and then compare the two situations or compare the multiple situations. This concludes this video on important financial calculations that you need to know to be an analyst. I'd like to say thank you for watching. This video was copyright 2020 by James M. Renault. All rights reserved. If you need to contact me, you can email me at jrenault@shawnee.edu. Thanks again.